Alrighty, a little late, a little late. Also, looks like it's gonna be hard, so Eeks. Minimum operations equalize binary string. You're given a binary string S and integer k. In one operation, you may choose exactly k different indices and flip each from 0 to 1 and from each 1 to 0. Okay, just flip them. Return the minimum number of operations to make all characters in the string equal to 1. If it's not possible, return -1. Operations to make all characters equal to 1. So you can flip the 0 to 1. You can flip 3 of them. So you flip the 0, 0. Flip the 1. Flip the 1, 0, 1, or the 0, 1, 1 over here. You flip the 1, 0, 1 here, that'd be 0, 1, 0 at the end, and then you flip the 3 zeros. This seems like a math problem. Seems like a math problem to me. The order literally doesn't matter the order of indices, right? Because you just choose k indices. So it all depends on the number of zeros, the number of ones, k, and if it's possible. Like you just order all the zeros and ones at the start. All the zeros at the start, all the ones at the end. Okay, so this is just a math problem. I'm not sure why, because you're not going to actually try to simulate the flipping. Okay, so what the question is just what was the math behind it? So let's say I have arbitrary amount of numbers. Let's say it's like 9 zeros, and let's say there's 15 ones, and let's say k is, let's say 3. Obviously, you just, if the number of zeros evenly divides into k, even divides by k, then you just, and that gives you the number of operations, right? The number of zeros divided by k. So the question is when it's not evenly divisible. Actually, let me look at example 2. So you have 2 zeros, 2 ones, and k is 3. Would it ever make sense to... When would you not want to do the greedy approach? The greedy approach is just using your k. Well, definitely this one you don't want to use the greedy approach. If you spent all 3 flips on your zeros and then 1 on your ones, you'd left with 1 0 and 2 ones. No, 1 0 and 3 ones. So you want to make your, so the goal is to get to a state where the number of zeros is a multiple of k. Least moves, a move is an operation, each least operations to get count of zeros to be multiple of k. So on any operation, assuming large enough zeros and ones, I think you can flip k zeros or kind of the multiples or kind of an even amount less than that. So if you have k is 3, then you can choose 3 zeros, even though that's not possible here. 3 zeros, in theory, if this was like more zeros. 3 zeros, 1 0 and 2, 1 0 and 2 ones, or 2 zeros and 1 1, or 3 ones. So you can change the amount by plus, so it'd be like +3, +1, -1, -3 in terms of affecting the number of zeros or ones. If this was k is 4, then it'd be something like +4, +2, 0 in theory, which is obviously not what you want to do. That's assuming that k is not kind of larger than the number of ones or zeros, or like the value that you're switching off. Huh. I think I can probably do the trivial case in terms of the not possible pretty easily, because these things are gonna cause the amount to be a certain difference from the starting amount. So why was this thing not possible? So for that one, you're starting off with 2 1s and 1 0, 2 1s, 1 0. K is 2, so it could either increase by 2 or decrease by 2. So then you just toggle from how do I want to think about this? A equals 2. So if I toggle 2, these 2 1s, I can make them 3 zeros. At that point, I have an odd number and k is even. If I have an odd number of zeros and k is even, I don't think it's possible. Yeah. Odd number of zeros, even number for k. Is it? If I have an even number for k, A is like, let's say 6. K is 6. Then it's like toggling 6. 6 zeros. If there's an odd number of zeros, I would need to toggle 6, 5, 1, 4, 2, 3, 3. Yeah, it's not possible. Okay, let's say zeros is equal to, I'll say n is the length of the string. Let's say zeros equals s dot count. Counts zeros. Ones is s dot count, or s n minus the zeros. Let's go ahead and print that out. Make sure I'm doing this correct. Okay, there's 1, 0, 2 ones. 2, 2. Okay, and then I think the basic premise would be something like trivial case not possible if odd number of zeros and even k. If the number of zeros is odd, so divide by 2 is remainder 1, and k is even, divide by 2, remainder 0, turn negative 1. So then there's kind of 3 other cases, like odd 0, odd k, even zeros, odd k, even 0, even k. Do any of those other ones fail? I think the other ones are fine. The other ones are fine for some reason. I think that there might be another case that would be wrong, but if there was a odd number of zeros, no, if there was an even number of zeros and odd number k, thing is like that's, you could do k twice and get kind of an even number of zeros and an even number for k. I think even number of zeros, odd k should be fine. Even number of zeros, even number k. Even number of zeros, even number k. Could that just not work out? 5, 5, 6, 4. Even number of zeros, even number k should work out. Yeah. Okay. Odd number of zeros, odd number for k. Is there other ones that could not work? Like maybe somehow if they're relatively prime or relatively not prime. They're like a multiple of each other. They're a multiple of each other. There's that's a thing. and 1. N to the 5th. I wonder if I can do this dynamically. So if I start with the number zeros as kind of the whatever makes sense to go up in the number zeros. I guess it would. Went up in number zeros here because it had to. Generally, you want to go down in number zeros. Hmm. Okay, so 0, 1, 1. A is 2. So 1, 0, 1, 0, 0, 0. Those are the two possibilities. 1, 0, 1 doesn't change anything, right? Okay. Example 3 is try 0, 0, 1, 1, case 3. So there's only two options. It's going to be like 1, 1, 0, or flipping the last three would be 0, 1, 0, 0. So that's so going from 2 to so 0 2s to 1 2, or 2 zeros, or 2 zeros goes to 1 0, or 3 zeros. 3 zeros matches K. K can be the length of the string. Makes sense, makes sense. For the single operation, try and get to the multiple of K. Multiple of K. Number of zeros is a multiple of K. Number of zeros is a multiple of K. So if I think about a number line, where on the number line there's like spots where it's a multiple of K, and I'm trying to move the current number of zeros to one of those spots. Move the current zeros to one of those spots. And the movement of the current number of zeros can be like 1, 3, 5, -1, -3, -5. If k is odd, assuming that there's enough to transfer. Assuming that there's enough to transfer. I wonder if this can be done. Using dynamic programming, I want to say. Dynamic programming. Doesn't quite work out because of the number of zeros and ones. So if you remove we have 3 zeros. Two zeros, 2 ones. So if you had this thing, this second example is actually probably good enough to try to figure out what the correct algorithm is, or the simple algorithm that would solve it would be. So k is 3. So if k is if you're, I think maybe if you initialize your an array to be like, let's say infinity, 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 infinity. So if you're at 0, and let's say you initialize 0 to be 0, which is to say that if you have 0 zeros, your answer is going to be 0. So you should be able to change k away from that spot to be 1. Because you're then toggling k zeros to be all, or yeah, k zeros to be all ones. Then the question is, how would you go from there? And then you toggle the things next. Toggle the things next to it. Because k is 3, So that means you can do 1, positive 1, negative, positive 1, negative 1, positive 3, negative 3 from there. So these would be 2. And this would be 3, I guess. So if you actually started with 0, 1, 1, 1, 1, 0, 3 ones, it should take you 3 steps. So you probably you can either change it to all 4 zeros, or you can change it to 2 zeros. So you change it to all 4 zeros, then you can change it to be you can change, actually that doesn't work. It doesn't work at all. If you have 1, 0, you can make it 4 zeros. Yeah, my math is somehow very off here. So if you have 3 ones, or this is, so if you have all zeros, one step is going to go to what does this 3 represent? This 3 represents the number of, am I doing this in the backwards fashion? 0 is the number of zeros. 3 is the number of zeros. Okay, 0 is the number of zeros. So this thing represents all ones. And then, okay, yeah. Okay, yeah. So if you start with 1, 0, so it would be 0, 3 ones. You could make this into 4 zeros. No, I'm still doing it wrong. You could definitely make it into 2 zeros by flipping something like this. Then how would you make 4 zeros into 3 zeros? You can make 3 zeros into 4 zeros now. 3 zeros into 4 zeros. Can't do that. You can only make into, I see, because there's only 1 1 here. If there was more ones, then you could increase the number of 0 by 1. I see. Or I think I see. So 3 can only go down to 2. Can't go up to 4. Sorry. So it should be 1 step is here, 2 step is here. And then 3 step is here, 4 step is here. 4, okay. Seems like this would be a heap, kind of a number of steps, dynamic programming heap, maybe. I guess maybe this really isn't dynamic programming. It's just kind of like a heap. Hmm. So let's say min steps is going to be infinity times n, so number of steps it takes to get to a certain value. I guess maybe I can do the other trivial case, which is if the number of zeros is divisible at k, then return the number of zeros divided by k. So you take each operation just removes k zeros. Min steps of 0 equals 0. I think it's actually this should probably be n plus 1. Guess this kind of does work with dynamic programming then. This is track least number of operations. I guess maybe I'll call it operations instead of steps. Min ops, least number of operations to get to a particular value, particular count of zeros. So here the key is the count of zeros, or key being the index, count of zeros, and the value equals the minimum number of steps. Operations. So obviously if you have 0 zeros then you're done, so it's 0 operations. I think I need to do a stack. Stack. Is it stack or is it heap? Or is it a deck actually? Yeah, it might actually be a deck. Where the deck is, I'm on a count of zeros. Yeah. So let's go ahead and say the current number of operations, no, the current numbers, the current number of count is going to be deck.pop left. If the current count is equal to k, return is if it's equal to k. Actually, I think it's equal to number of zeros. Return. There's some optimization here that I'm missing. Return min ops of this current count. Maybe I should be doing this later actually. I should maybe do that during the process. Okay. Okay, so I think I can do. Oh no. K being the length of this string. That means I'd have to go through all the possible transfers, which is too long. Oh, shucks. I think it's too long. Because if k is something like 100, then I have to go like plus 100, plus 98, plus 96, plus 94, plus 92. I have to do that each time. I was hoping maybe I can just go upwards. It just goes upwards. It's possible that it misses it. It's definitely possible. 0 to 3. 3 needs to go down to 2. Interesting. I'm gonna go up over. K was 5. So if it's 5, 3, 6, 9, 10, 20, 30, 40, 50. K was even. Wonder if it's just going upwards by K each time. Going upwards by K each time. But then if going upwards by K is past the length of the string or more than the number of zeros, then I have to go down. I have to go down. I guess that might limit. Then I wouldn't be able to go down. If K was initially, let's say 1,000, the string length is 1,000, and number of zeros is like 500. If I go upwards, from the number of zeros from 0. Upwards from the number of zeros from 0. If there's 0 zeros, then you have to go all the way to you have 0 zeros, then the only operation you can go to is K zeros. And then from K zeros, you can either go more zeros or less zeros. More zeros or less zeros? Up to some amount. In order for you to go more zeros, then you need to have enough ones to exchange for that. Seems like a number theory problem, to be honest. Some sort of modular arithmetic I should be able to do. Up K. Have to go up K. Can't go up K minus 2. There's not enough zeros there. At that point, you have some number of zeros and ones, maybe. You have some number of zeros. This doesn't seem like it should be a hard problem. Should be a medium, which means I should be able to do it. You can flip. Matters is the count. All that matters is the count. Let's say there's like 500 zeros, 1,000 ones. K is 1,500. So right now there's plus 500 ones. If I think about just the difference between the number of zeros and ones, just the difference between the number of zeros and ones, let's say, so if the string length is 1,000, or length is 1,500, then the range of values is going to be 1,500 to negative 1,500 is the net difference. Let's say this is ones minus zeros. And I'm aiming for plus 1,500. Right? Aiming for them all to be ones. If the net difference, zero net difference just means that there's equal amounts, so there's 750 zeros, 750 ones. How does K come into play? So my initial value, initially if there's 1,000 and 500, that means it's plus 500 difference. And let's say K is, well, K is 500, then that's just 1. K is 1,000. No, let's say K is K is 33. So here I should just remove K from the difference each time until it's something closer, right? So closer would be 99, 198, 297, 396, 495. So 495 subtracted from the net difference would be 5. That would be like 15 operations, 5 times 3. So then what? If it's plus 5 difference and K is 33, then there should be a breakdown there that works, right? Like you flip over 8, 17, no, 19 and 14, 19, flip 19, 14 somehow. No, that doesn't work. What am I doing? I want to get the difference to be, I need 5 plus 28. So I need a difference of 28, which isn't possible. Huh, it's not possible. Let's actually get the string. Oh, that's disgusting. I'm just gonna write down the numbers. So 5 plus 5 difference of plus 5 doesn't work, does it? Does it not? So plus 5 means I need 28 more. And if I get 28 more, then if K is odd, I don't think I can do a change that's even. What is wrong with this? So if this was plus 38 plus 38, so this was like 462 plus 38. So here I need to switch 7. I need to flip 7, I think. What am I thinking of? So I want to get 38 down to 33. So yeah, so flip difference of 5. Difference of 5 would be 8, 1914. Flip 1914 here. If I flip 1914 there, then so then that could somehow make it this to be 33 difference. So 500 zeros down to 14 operations of flipping all 33 zeros. I'm down to 38 zeros, 38 zeros. I flipped 19 zeros and 14 ones. No, sorry, I flipped 19 ones and 14 zeros. No, I flipped 19 zeros and 14 ones, yeah. 19 zeros, 14 ones means I lose 5 zeros. So then I'm down to 33 difference, and then I flip one more. So I think maybe you should always try to flip all you can. Flip all you can if it's more than 2 times k. If it's more than 2 times k. Is that the relevant range? From 0 to 2k, is that the relevant range? So from 0 to like 66-ish. Because something that's between 33 and 66 could, in theory, go down to 33. That's not inclusive of 66. Or in theory, something that is below 33 can go up to 33. And then everything else can transfer to something in that range. Do, 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 33. So I mean, I guess still can be rough because k could still be the length of the string. But maybe I'm just thinking about going downwards. So the first thing that's above k to 2k, I need to slow down. I need to slow down, consider not, I should be going up or down. Starts with some number of zeros, goes up, start with some number of zeros, like 2 zeros. K is 3. 2 goes to 0. 2 has to go down to 1. 1 has to go down to 1 can go down to 0. 1 can go down to 0. 2 can go down to 1. Two zeros. But if there were 2 zeros and k was 3, and there was only 1, 1, I don't think that works, right? Yeah, you'd have to go 1, 1, 0, just toggling it back and forth. Two down to 1, 1 down to 0 is not possible. 2 zeros down to 1, 0, 1, 0 doesn't go down to 0, zeros. Lippity doo da day. Seems like it should be such like an easy number theory problem. Really, this is like a math problem. Maybe there is coding here. Maybe I should not be trying so hard on coming up with the math. How would I solve this coding-wise? 0, 0, 1, 1. So if I simulate the number of zeros and number ones, simulate the number of zeros and number ones. The minimum between the zeros and ones is the upper bound of the range of the switch, right? If there was another 1 here, there was number 1, quite. So k can toggle 3 here, but there's only 2 1s. So it can only toggle 2 1s rather than 3 1s. Well, what am I thinking? This is wrong. Correct solution was going upwards, right? It was going to from 2 zeros to 3 zeros. So and then you have 3 zeros, and you want to make them all 1s. This thing would be easier if it was flipped the other way around. Minimum operations to make the string all zeros. In any case. Alright, well, there's only